Hey guys, so these are from the cumulative review, but these are the ones that specifically have to deal with the volumes. And I wanted to do these so that we could maybe get a better handle on some of them. And for me, I always need to kind of draw a rough picture of this. And so as I read through this problem, I have the region enclosed by y equals x squared, the line x equals 2, and the x-axis. And I'm going to be revolving this around the y-axis. So if we just draw a rough picture of what we have, I have y equals x squared. Y equals x squared. The line x equals 2. And the x-axis. So there's my region, and we're going to be revolving this around the y-axis. I don't know why I did that in red, sorry. So revolving this around the y-axis. I'm starting on my axis of revolution, and I'm drawing a line through my regions. So if I draw a line through my regions, starting on the axis of revolution, x equals 0. This next point is the red point. I need to know that x value in order to find the distance between them. So if y is equal to x squared, well then x is equal to the square root of y. So x is equal to the square root of y. And then we have the blue point. And that x value is equal to 2. So our outside radius is going to be the distance starting from that axis of revolution. Distance from 0 to 2 is 2. The distance from 0 to the square root of y is the square root of y. So now when we go to write our definite integral, volume is equal to, because we're revolving it and we're going to be taking the area of circles, pi times the definite integral of our outside radius squared minus the inside radius squared with respect to, because our integral has y's with respect to y. Now our lowest y value is 0, and this upper y value, well, if y is equal to x squared and it ends when x is equal to 2, then y is going to be equal to 2 squared, or 4. So we can rewrite this because we know that 2 squared is equal to 4, and the square root of y squared is equal to y dy. Now it's time for us to take that antiderivative. The antiderivative of 4 is 4, and now if our taking the antiderivative with respect to y, it will be 4y minus y squared over 2 from 0 to 4 times pi. Plug in 4. 4 times 4 is 16, minus 16 over 2 is 8 pi. 16 minus 8 is 8 pi. All right. Y equals 4x squared. X equals 1. X-axis. So let's just draw the region. 4x squared. Y equals 4x squared. X equals 1. X equals 1. X-axis. Okay, so there's our region. And each plane of this, each cross-section of this solid is a square. So perpendicular to the x-axis, so draw a vertical line because that's perpendicular to the x-axis. And if we think about that square, the top of that square is y equals 4x squared. And the bottom of that square is y equals 0. So if this is a square, this side length will be 4x squared because that's that distance. And because it's a square, this will also be 4x squared. So inside here, this area will equal 4x squared quantity squared. 4 squared is 16, x squared squared is x to the 4th. To write an integral expression for volume, we want to add up all of the areas of those squares. So each square has an area of 16x to the 4th with respect to x. So my lower x value is 0, and my upper x value is 1. The antiderivative, 16x to the 5th over 5, evaluating this from 0 to 1, and then 16 over 5 minus 0. So I think we all remember what that graph of the sine of x looks like. And so now we're doing it from 0 to pi over 2. So from 0 to pi over 2. So here was pi over 2 from our old pre-calc days. And so we're looking at, this region here. And so if I want to revolve it around the x-axis, let's draw a line. And we know that the x-axis has a y value of 0. This top point is y equals 1. And this point here in the middle is y is equal to the sine of x. The outer radius is going to be the distance from 1 to 0, which is 1. The inner radius is going to be from 0 to the sine of x, so the sine of x. Volume is equal to, because we're revolving it, we're taking the area of circles, so pi times the definite integral of our outer radius squared minus the inner radius squared with respect to x, so from 0 to pi over 2. Now we're pretty much done. It's just that 1 squared is equal to 1, and the sine of x quantity squared can be written as the sine squared of x. Right. X is equal to 0, y is equal to 5, y is equal to x squared plus 1. X is equal to 0, y is equal to 5, and x squared plus 1. We're revolving this around the y-axis. So here's a line that goes from my axis through the region. We know that this is x is equal to 0. So this x value is equal to what? That's a terrible x. This x value is equal to what? Well, if y is equal to x squared plus 1, y minus 1 is equal to x squared, so x is equal to the square root of y minus 1. The distance from here to here is the square root of y minus 1. Volume is equal to pi times the square root of y minus 1 squared with respect to, and now with respect to y, so our lower y value is 1, our upper y value is 5, because it goes from 1 to 5. Now, we can rewrite that, pi, definite integral, from 1 to 5. The square root of y minus 1, quantity squared, is y minus 1, dy, antiderivative, y squared over 2 minus y from 1 to 5 times pi. Now when we plug in 5, we get 25 over 5, 25 over 2, sorry, minus 5 minus the quantity 1/2 minus 1. (25 minus 1 divided by 2 is 12 minus 5 plus 1 is equal to 8, and then don't forget out the pi. I'm going to do this one underneath, just so that we have more space. Okay, so now if we're revolving this region around the y-axis, let's draw our line from our axis of rotation through that region. So we have a horizontal line, and we know that this x value is equal to 0. We know that this x value is equal to y squared, because if we were to square both sides, x is equal to y squared. So that makes this distance y squared. Volume is equal to pi times the definite integral of y squared squared with respect to y. And so if this is with respect to y, our lowest y value is 0, and our largest y value is 2. Well, pi times the definite integral from 0 to 2 of y to the 4th dy. The antiderivative of y to the 4th is y to the 5th over 5 from 0 to 2. Don't forget to multiply by pi. 2 to the 5th is 32/5 pi. All right, hopefully that cleared some things up. I'm going to try another video too, and hopefully that works. Let me know if you have any questions.